Okay. When you've got a problem like this, versus, I think this is the one we did in class. All right. We talked about the fact that I get a lot of students that work equations and inequalities the same and then not remotely work the same way. Okay. So the here, you factor it. And this says that one number times another number is 0. Well, when you multiply two numbers together and the answer is 0, what do you automatically know? One of those numbers must have been what? 0. Okay? So you either get x is 3 or you get x is what? -2. In other words, either this thing is 0 or this thing is 0. So unfortunately, people want to do this one the same way. Okay? So the first step is the only thing that's the same. So they want to say, well, either x minus 3 is greater than 0 or x plus 2 is greater than 0, and that's just not right. Now look what this says. This says when you multiply this number times another number, what was the answer? Positive. Well, what do you know when you multiply two numbers together and the answer is positive? They're either both positive or they're what? It's not that this one's positive or that one's positive. You know, first possibility is this one's positive what? And that one's positive. What's possibility number 2? They're both negative. So this would be negative, not or, but what? And that would be negative. And I think that's the way I worked it by cases that day. Now, the only problem with cases is by the time we get to the third test, they're going to be like 5 of these things. Now think about it. I would not, okay, if you had 5 factors, how could the answer be positive when you multiply them all up? What's one possibility? They're all positive. Okay, what's another possibility? Are all negative going to work? No, what's going to work?
4 negative.
4 negative, which 4? It could be these are negative and that one's positive. Or it could be this one, this one, this one, this one are negative and that one's positive. Or it could be these two, you see what I'm saying? Or it could be 2 are negative. You see, I would have like 7 pages of cases. So to fix that, I always work on using a split point table. Now, I'm not saying you have to. I'm saying that's the way I'm going to work them because it's fast and efficient. The reason I don't show it first is because you don't have to really understand what you're doing to get the right answer. I like you to understand the cases first. So I'm going to rework this problem that's already in your notes with cases. I'm going to rework it with a split point table. Okay? Now, here's what you do with a split point table. You do the factoring. Okay? So I've got over here x minus 3 times x plus 2, but I'm going to change it and do less than 0 in order to kind of answer Will's question. Okay? Now, this time, I know that when I multiply 2 numbers together, the answer is what? Negative. So that tells me either what? This one's negative and that one is positive. Or this one's positive and that one's what? Negative. So I still have 2 cases. But instead of doing cases, what I'm going to do is come over here to the side and do a split point table. Now, on a split point table, you put every factor over here with its split point on top of a number line. Now, what do I mean by that? What's one of my factors over there? 3. Not the factor, not the split. X minus what? 3. That's a factor. A factor is something you multiply together. Okay? The factor of 6 will be a 2 and a 3. Okay? This is a factor. Now, what's the split point for that factor? A split point is where the factor equals 0. So what's your split point for x minus 3? When does x minus 3 equal 0? When x is what? 3. Okay? So I've got a number line down here. And I'm going to put the split point on that number line. Now, what you're going to do is you're going to substitute a number in smaller and write down whether the answer is positive or negative. Then you're going to plug in the number that's bigger than your split point and write down whether it's positive or negative. Now, I don't care what number. I just need a number smaller than 3. Give me a number smaller than 3.
1.
1. What's 1 minus 3?
Negative.
What, negative or positive?
Negative.
Negative. You get negative numbers. Now, if somebody else had grabbed 0, they'd have gotten a -3 instead of a -2, but it still would have been what?
Negative.
Negative. That's why it doesn't matter what the number is as long as you're on the correct side. Okay? Give me a number bigger than your split point. Give me a number bigger than 3. 5. What's 5 minus 3? It's positive, right? It's a 2. That's as hard as it gets. I just do that for every factor. What's another factor over here? Not 2, but what? X plus 2. Now, its split point isn't 3. What's the split point for x plus 2?
Negative.
Now, I'm not trying to draw it to scale, but it is a number line, so do me things on the correct side. So is a -2 to the left or to the right of the 3? It's to the left. Now, again, I'm a visual learner, so it helps me when I color code. All I'm looking at is the blue factor and the blue split point. Give me a number smaller and bigger if I can write it down correctly. All right. So give me a number smaller than -2 to the left of the -2. -5. Okay, what's a -5 plus 2? Negative. If you picked -10, you'd have a -8 instead of a -5, but it would still be what? Negative. Okay, give me any number, give me an easy number. I don't like to do stuff in my head. Give me an easy number bigger than -2. 0. What's 0 plus 2?
2.
Is that positive or negative? So by test 3, if you have 5 factors, you're not going to care. Your table's just going to be a little longer. Is everybody with me? All you're ever doing is putting a factor over here, looking at the split point and picking a number smaller and bigger and plugging it in and saying if the answer is negative or what? Positive. Now, the reason they're called split points is if the sign is going to change or split, that's where it's going to happen. Now, sometimes this will be negative all the way across. Sometimes it'll be positive all the way across. Sometimes it'll be negative and turn positive. Sometimes it'll be positive and turn negative. How do you know? Substitute the numbers in and see. You can do arithmetic. Now, when you get all the factors on the table, whether they're 2 or 22, doesn't matter. Do what it says. Doesn't that mean to multiply parentheses? Okay, well, what's a negative times a negative? It's a positive. What's a negative times a positive? A negative. What's a positive times a positive? Now, for the first time, I care whether this says less than 0 or whether it says greater than 0. The only difference is what I pick for the answer. What kind of answers are less than 0?
Negative ones.
Negative ones, right? Where's your final answer negative?
In between.
In between. Now, you can write it like algebraic, in between -2 and 3. But the back of the book is going to put it like this. That means all the numbers starting at include or don't include. What's that parenthesis mean? Don't include. What's that parenthesis mean? But all the numbers between the two. Now, if it had been the original problem where I had greater than 0, I wouldn't have picked this. I would have picked what? This or what? That one. Now, let me warn you about something. I get this a lot on the test. So if I were working this problem, I would look over there and I'd say, well, my final answer is positive to the left of a -2. So I would have x is less than a -2. And you said, it also works if x is bigger than 3, right? If you write and in there, I'm going to write you a note. What number is that? Because when you say and in mathematics, it means simultaneously. And personally, I don't know of a number that's smaller than -2 and bigger than 3 at the same time. If that's the answer, then the answer is no solution. If you're telling me that this is an option plus this is an option, you with me? That's not an and, that's a what? That's an or. Now that's the right answer to this problem. But I wouldn't have worked it any differently. It'd have been worked the same. I would just been picked a different number. Now, this is not a trick question. Pronounce that word. Read. Could it be red?
Yes.
How do you know that it's red and not red? Or how do you know it's red and not read? Context. The same thing. When I have something like this out of context, I assume it's a point. Because I see points more, does that make sense? But in that context, it's not a point, it's an interval on the number line, okay? But if that bothers you, you can always use algebraic notation, whichever makes more sense to you. Was that kind of part of your question, Will? Okay. All right, everybody okay? Now, you had that trig review that was that video. Was that helpful? Okay. So do y'all feel okay going from degrees to radians and radians back to degrees? Everybody good with that? All right. Because they're never in this book ever going to let you use degrees. All right. They're going to make you use radians because radians are real numbers. So you can put them on a number line. That's why when you go to graph trig with that grapher, it doesn't have degree, it has radians down there. Because it's a number line on the x-axis, we mean a number line here. So they're going to do radians. So now, you can do your stretch work in degrees all day. So you feel free to do that. Now, that brings me back to one of your problems on your review sheet was an inequality like this, but you had to factor using the quadratic formula. So you got a real funky answer if you did it right. So you got something like, I remember it was like -4 or 4 plus or minus, like 3 to the square root of 2 over 2 or something. I mean, you know what I'm saying? It was a really weird answer. So when you factor with the quadratic formula, it's always x minus and x minus. Now, I haven't worked in 100 years. Do y'all remember if you got like, was it -4, 4? What was it? Do y'all remember? -4? Okay, say it's this. I'll double check it. I don't remember. Let's just say greater than 0. Do you understand? I would make a split point table. But I don't know about you, but I have a hard time finding a number to the left of that. Everybody with me? So what I would do if it were me is, in my scratch work, I would get a decimal approximation. So I don't remember, maybe like point, maybe 2, I don't know. And that's x minus a negative, it's gonna make it a plus. Is everybody with me? I don't remember. Because I can think of a number to the left of 1900s. I know -100 is smaller. I can think of a number bigger, I know 100, you see what I'm saying? Then when I get my answer, I don't remember what the answer is. Say the answer is x is to the left of 9/10. Well, it really wasn't 1900, so right with me? Then I would just slide the actual number back in there. So I didn't say you couldn't do decimal approximations in scratch work. I said I didn't want decimal approximations for final answers. So sometimes it's an advantage to switch to something to work because you work better with that and then switch it back. And so for a lot of people, they think better in degrees than they think in radians. Some people don't. But I need the answers in which one? The radians. Okay? The other thing you got to be able to do off that worksheet, and then it's talking about it here, kind of on page 31 in your books, you got to be able to give me exact answers. If I say something like, what's the sine of 3 pi over 4? Or what's the cosecant of 7 pi over 6? Now, you don't have to get it immediately, but you know, in a minute, you should be able to sketch it out and give me that answer. So does everybody feel okay about that after watching that video? Are we okay? If you're not, let me know or come see me. Is everybody with me? One of the two. We can do it now or do it later. Now, that's when I give you the angle and I want what you think of as the answer. Now, another part of that video, another thing you got to be able to do is you got to be able to go in the reverse. If I give you the answer, can you give me the angle that would have given you that answer? So that was the ones where it was like sines of -1/2 or cosines of -square root of 3 over 2. So what's your angle? Well, there you build the triangle and then figure out what the angle is and adjust the quadrant. Now, again, there were a few of those on the video. Did that make sense to y'all? Okay. All right, I'm trusting you then. All right. So now there are 3 identity. You know, I told you you have to memorize everything from trig, right? But here's what you do have to know. Okay? You got to know your trig identities in words like adjacent, opposite, and hypotenuse, or I'm going to lose you in a little bit. So you should be able to tell me that tangent of an angle is the opposite side over the adjacent side, or that sine of an angle is the opposite side over the hypotenuse in words. The other thing you need to know is that in terms of x's and y's, or I'm gonna lose you. Does cosine depend on x or y? Do you remember? X. And sine depends on y. And then tangent depends on? Right, both of them, right? And then they have reciprocal functions. So if sine depends on y, that means cosecant depends on y. If cosine depends on x, that means secant depends on x. Everybody with me? So you got to know that. Now, there are three identities that you have to memorize if you don't know them, and that's these Pythagorean identities, because they're going to pop up. So sine squared of an angle plus cosine squared of an angle, do you know what that equals? 1. All right, and then it reminds you that 1 plus tangent squared of an angle is secant squared. And then it reminds you that 1 plus cotangent squared is cosecant squared. So those three Pythagorean identities on this review, on this formula sheet, you do have to know. Now, we might end up using like a power reducing formula or a double angle formula or some difference formula later, but I wouldn't expect you on a test to have that memorized. But I would expect you to have those three Pythagorean identities memorized. Okay? So make sure that you kind of make a note to yourself about that. All right. Now, let me look at something. Trying to see what else they've done in this trig review in your book. Good there, good there, good there. I think we're all good. Now, what I don't want you to do is panic over something. Again, I don't remember exactly. I mean, I worked it with somebody yesterday, so maybe. There was something on your review sheet that was somewhat like this, I think. Right? All right. Now I'm going to change it. If I told you to solve that, you've solved that 1,000 times in your life, probably. Okay. Now, more than in other words, it'd be like solving x squared minus x minus 1 equals what? 0. But the one I gave you was like that, so that'd be like x squared minus x equals what? It's just something squared minus that same something is 0, right? So how would you work this problem up here? Wouldn't you factor what's the same out? What's the same thing here? What's the same? Sine theta. So factor it out. What's that going to leave you? Another sine theta minus what? 1 would be what? 0. So it's a problem similar to that. Obviously exactly that. Everybody okay? Now, luckily, this is a quadratic equation. That's quicker than inequalities. So that says you multiply two numbers together and the answer is 0. So what do you know? You told me a second ago. One of them is 0. So either sine of theta is 0 or sine of theta minus 1 is what? 0. Now, this one I already know. Now, are you going to get a 0 off of a triangle? No. All right, same thing here. This would be sine theta is what? Are you going to get a 1 off of a triangle? Yeah, I can, but that's for tangent and for cotangent. These are going to come off the unit circle. Now, remember what I said about the unit circle? All I know about the unit circle is what's the radius? 1. Okay? So if the radius is 1, what's that point right there? 1, 0. What's this point up here? 0, 1. What's this point over here? Negative 1, 0. What's that point? 0, negative 1. Does sine depend on x or y? Y. So look on that circle and find me where y is 0. Where's y 0? What is 0 what?
0.
Right there. And 0 what? Right there. So one of my answers would be a 0, right? What's this answer going to be? Pi. It's 180, right? Could you keep going and come back around?
Yes.
And what's that going to be? 2 pi. Could you come back around? What's that going to be? No, don't panic yet. Is everybody with me? Is that ever going to end? It's not, is it? Now, what if instead of going counterclockwise, what if you went clockwise? Well, if you went clockwise, instead of going from here to here this way, what if you went from here to here that way? That's a negative pi. What if you went again? Negative what? 2 pi. You see that? Do you see that you have an infinite number of answers? So to keep you from having an infinite number of answers, there was something in the directions.
Oh, balancing.
That's what that was for. Now there's 2 ways that I phrased it. I phrased it one way on one set and one way on the other set to make sure that you're clear. What if I did that? That says go from 0 to what? 2 pi. Do I include 0?
Yes.
Yes. Do I include 2 pi?
No.
No. So if this was the directions for this, then what would my answers be? I want to throw everything out that's not in that interval, right? So that would change this answer to just what?
0.
0 and pi. Now, what if there was an equals there?
2 pi.
Now it's 0 pi or what? 2 pi. Same thing. Sometimes I'll do it this way. That also says that your angles are an element of this set. So they're between 0 and again and what? 2 pi. Include it what? Don't include it. So for that to be the answer, I would need a what there? A bracket. Okay? So the reason that those directions are there, so you don't keep writing down an infinite number of answers. So they're a big deal. Notice the directions. Because if they're missing on a test, then I expect to see something like that. Like, you know what I'm saying? Like, good luck. All right. Now, so if trig is a problem for you, then I'm gonna give you part of your homework for tonight is going to be a review sheet with trig. Okay, I'm gonna give you some problems. They're on a sheet. I might give you some in the book. I haven't decided yet, but I'm gonna give you a worksheet just to give you some more practice on trig. Now, what we're gonna do next is talk about inverse functions. Now, the reason we're doing that is this. Today, we talked a little bit about trig, and then we talk about inverse functions. Because what I really need to talk about is inverse trig. Well, I've got no hope of you doing it backwards unless you can do it frontwards. Is everybody with me? That's why the worksheet tonight is going to be on trig the regular way, along with some inverse problems. And then next week, we're going to do both of them together. Okay? So it's going to be a lot more like, usually you give somebody an angle and they give you an answer, but next week I'm going to give you the answer and you're going to give me the angle, but it won't necessarily always be a special try. Yeah. See, the fun just continues, doesn't it? Oh my gosh! Oh, I love it. Okay, now. All right, so let's talk about inverses. All right. Inverse functions. Now, before I write down the formal definition, now remember I'm going to ask you for definitions on the test, and they're not going to be matching or fill in the blank. It's going to say just define. So you start learning them. Okay? But before I give you the formal definition, let's just understand what it's talking about. What do you call the things going into the function? The domain. What do you call things coming out of the function? The range. The inverse switches them. It switches them. Now, with that said, here's what I mean before I write the formal definition. What if f of x was this list of points? Three points. What would the inverse be? Now, what did I tell you happened with the domain and ranges? They flip. Now, if the domain, the x's or the y's? X's. So, what would be the 3 points in the inverse of this function? 3, 1, 5, 2, and what?
-8, 3.
Negative 8, 3. That's what happens on inverses. The domain and range is just what? They switch. So if 2 is coming in, now 2 is going to what? Wow. If 8 was coming out, now 8's what? Coming in. Now, in order to emphasize inverse, now they're going to talk about it with F's and G's, but a lot of times in your book, if they want to emphasize that this function is the inverse of that one, instead of naming it a different thing the way they do in the definition in a minute, they're going to do it like this. That notation of a -1 right there means inverse. It's not this. Those are not the same thing. Because in algebra, you learn what's x to the -1 the same thing as? 1 over what? X. Do you see what I'm saying? But that's when you have the whole thing to a -1 power. This -1's between this f and this x. Is everybody with me? So these are not the same things. I don't want you to get them confused. All right? I don't use this notation in the definition because I don't want it to be problematic when you're doing manipulations. All right. So here's kind of your definition of inverse functions. F of x and g of x are inverse functions if and only if f composed with g of x and g composed with f of x equal x. It's got to work both ways. So you might want to write it this way just to emphasize. So f composed with g of x equals x, and g composed with f of x equals what? X. It's got to work both ways. Now, in math, a lot of times, we have our own language, okay? Part of the reason for doing that is it's universal. So if I pick up a German journal, math journal, I can read a lot of it, even though I don't read German very well. I love that language because it's just so structured. Like the German word for watch, they just put the word clock on wrist and jammed it together. You see what I'm saying? Like, that's a language I can love. You see what I'm saying? Like, that is so logical. It is a watch on your wrist. Okay. So I can read a little German, but not a lot. But I can read all the math symbols. So I'm going to do things in words, but I'm also going to do things in symbols a lot just to get you accustomed to it. Every discipline kind of has their own symbols. Okay. The reason I say that is, my high school teacher used to write that on the board, and she was like 150, and so I thought, bless her heart, she didn't tell me. You know what I'm saying? Like, I wasn't going to point it out, you know, because it's sweet. Actually, that is mathematically correct for if and only if. So I really can spell it out. Okay. So we just do things very succinctly. Okay. Now, what do I mean by that? Okay, here's what I mean by that. They're going to give you two different functions and ask you things like this. If f of x, just do one out of your book real quick, is 2x cubed minus 1, and g of x is the cube root of x plus 1 over 2, are they inverses? Now, there's going to be a little statement right after that that prevents what you're about to do. If I give you that in a test, you can't go, yes, or no. You see what I'm saying? Because there's two little words you're going to see on your test a lot. Prove it. Okay? Now, it shouldn't bother you at all, because if you've been proving things since birth. A proof just means argue. And you've been arguing with your mama since you could actually physically speak. Are you with me? It's just, I'm going to give you points for it. But you're all really good at it. All a proof is telling me what you know and how you know it. It's just the how you know it can't be Jesus told me. It probably is true, but it has to be a mathematical reason. Okay? So a definition is always a great place if you don't know where else to start. So I'm going to be using definition. So for these to be inverses, I know that F composed with G has to be X and G composed with F has to be what? X. So let's go do those two. All right, you had composition the other day. You had some for homework. All right. So F composed with G at X. All right. Now, what's my G of X over there? What's my G of X equal to? What is it? Cube root of X plus 1 is right. So the cube root of X plus 1 over what? 2. All I did was put in for G of X what they told me G of X was. Now let me ask you this, just to make sure we're good. What if they had said do G at 3? What if they had said G at 3? What would they have told you to do? Are you messing with F or G? G. What would you have done? You'd have taken X out, and everywhere you see X, what would you have stuck in its place? 3. Okay, I'm going to do the same thing. Only when I take this X out, what am I going to put in place? I mean, when I take X out of my F, let me do that again. When I take this X out of this F, because it says put it in F, right? When I take that X out, what am I going to put in place of that X? This thing right here. All right? So I have a 2. Oop, there's the X. So what am I going to stick in place of that X? The cube root of what? X plus 1 over what? 2. Now, what am I going to do to that thing? I'm going to what? Cube it and then subtract what? 1. So all I did was go up here to F, and that X got replaced with that thing. That's what that means. Put that in F. Now, aren't you cubing a cube root? So what happens when you cube a cube root? Black is green. So what do I get? That cube and that cube root go out, right? Now we understand why, I'm hoping. Because what you really have in the cube root, the same thing as the 1/3 power. And aren't you cubing it? And what do you do when you have a power raised to a power? Don't you multiply them? And so 1/3 times 3 is a 1. So I end up with just X plus 1 to the 2 to the first power. So that's why it goes away. Okay? But I've still got a what stuck on the end over here? Minus 1. All right, what happens to those two? They divide out. So that leaves me what? X plus 1, but I still got this what stuck here? What do I end up getting?
X.
What was I hoping to get?
X.
X. Yeah. Now, am I finished?
No.
No, I've got to do it what? The other way. I've got to go both ways. Okay? So I've done F composed with G. So now I've got to go do this G composed with F. Okay? Well, what's my F of X? Your F of X was what? Wasn't it 2x cubed minus 1? Your G of X was the cube root of, what was it, X minus 1 over 2?
Or plus 1, sorry.
Okay. X plus 1 over 2. All right, so I'm going to replace this F of X with what F of X is. So I'm going to take that 2x cubed minus 1, and where am I going to put it? I'm going to put it inside of what this time? G. So what does that mean? That means now I'm going to the G function, right? And in this G function, what am I going to put 2x cubed minus 1 in place of? X. So I've got the cube root. Oh, there's an X. So I've got to put 2x cubed minus 1 in place of that x. What have I also got over there? Another what? Plus 1, and then the whole thing's over what? 2. So all I did was replace this x with 2x cubed minus 1. Now, is that parenthesis really doing me any good? No, so I can just get rid of it, okay? So what about those 1s? Are they gonna go away? So I have 2x cubed over 2, don't I? What's about to the 2s? They divide to 1, don't they? So I've got the cube root of x cubed. What's the cube root of x cubed?
X.
X. What was I hoping to get?
X.
So are these two things inverses of each other? Yeah. I used the definition and I proved it. Now, I know that y'all are brighter than some people that I've had in the past. Okay. But I put a problem on a test one time and I used C's. And a student told me, no, they were not inverses because he didn't get X.
I feel like it's not far-fetched.
I know, it's not. I mean, you're nervous, you know what I'm saying? So what I mean is you get the independent variable here. You understand what I'm saying? So like if it's in Z's, you should get what? Z. So I mean, he kind of, you know, like, touche. I did say that you should get X. But I meant kind of, but you know, they don't know what you mean, so I'm telling you what I mean. I gave him partial credit. I gave him a couple points. You know what I'm saying? Like, good for you. Way to go.
You knew the definition.
He did. That's what I'm saying. He did the right process. He just got the wrong what? Answer. So, you know, you're not going to be my doctor, but you know, you can be somebody, it's just not mine. You know what I'm saying? Like, you have cancer, but it's brain cancer, not liver. So I'm just saying, I do need it to be kind of right. So, you see my point. You get the independent variable, which usually is X, but not what?
Did they pass the class?
They did. He was really a bright boy. Man, sorry, he was a bright man. He was just very literal. Very, very literal. But I'm very literal, so I had empathy. You know what I'm saying? So I learned to communicate better thanks to him. You know, we're all in. Okay, now the other thing they're going to do is they're going to give you something and ask you to find the inverse if it exists. Okay? Now, f of x is this function. Does it have an inverse function? Write down what it is.
Wait.
What's bothering you, Lillian?
You don't have the set on the other side.
Oh, that should bother you.
Okay.
Yes, I'm sorry. Okay. Anything else bothering you?
3.
So what's the problem?
It's not a function.
I can do the inverse. I can flip, right? But the problem is when I flip it, I do need my braces, so thank you, Lillian. What's the problem?
It's not a
It's not a function. Why isn't it a function? Because you can't have you can't have one thing going in and two things coming out, right? So this thing doesn't have an inverse. So how are you going to know whether something has an inverse before you go to all the trouble of doing it? Because I mean, that's like a lot of wasted effort. It's got to be 1-to-1. So this one is a function. All right. But like CJ pointed out, but it's not a what? Now that's also a notation, 1-to-1. Again, that just saves me all that right. So if something is a function, it doesn't always have an inverse. Only one-to-one functions have inverses. So to save myself trouble, when somebody tells me to find the inverse, if it exists, the first thing I'm gonna try to figure out is what? Does it exist? I mean, I'm not gonna do all this over, and how am I gonna do that? It's gotta be what? One-to-one. Now, a lot of times, they're not gonna give you the list of points. So what's a quick way of checking to see if a function's one-to-one? We talked about what's a quick way to check to see if it's a function?
Vertical line.
Vertical line test. So it's gotta be a function, okay? So I better do vertical line test. But it's gotta be not only a function, but a one-to-one function. So I've gotta do the vertical line test, plus what have I gotta do? Horizontal line test. If you don't do that, I'm gonna nail you. Because you're gonna get a lovely answer, and I'm just gonna put, no, but thanks, I'm bland. Okay? So if you've got your graphers, then that's sweet, because you can just graph it. If you don't, you can make a T-table. If you've got a list of points, you can look at them. Is everybody with me? But before you start, I need you to decide, is there a function? So I'm gonna say, finding the inverse of a function. So we've agreed, let's not call ourselves lazy, let's call ourselves efficient. Okay, we're gonna be efficient. We're not gonna go hunting for treasure if there's no treasure to find. So the first thing we're first gonna do is determine if there is one. All right, and what did you tell me, how you gonna determine that? The function must be what? Must be a one-to-one function. And then you might write yourself a note. Note. What two tests are you going to do? Horizontal and what? So, do vertical and horizontal. So the horizontal's checking the one-to-one, the vertical's checking is a function. And I need both. I need to be a one-to-one function. Okay? Now, there are different ways of doing it, and you're welcome to do it any way you want to. This is just a way that always works. What did I tell you that happens with the domain and the ranges? They get what? Flip. They get switched, right? Then if it was me, I would probably solve for X or Z, the independent variable, shall we say? Okay. And then I would just switch X and Y. In other words, I'm going to switch the domain and the range. Now, let's do something fairly simple. What if I gave you that in the test and said, find the inverse if it exists? What are you going to say?
No.
No inverse, but then tell me why. What? No inverse because it's not what? It's not one-to-one. Because this graph looks like that, right? Game over. What if instead I did this? Now is it a one-to-one function? Because I don't want the whole parabola. I just want the parabola from x equal what? 0 up, right? So do you understand that's just that part of the parabola? Now is it a function and one-to-one function? Yeah. So now what? It's got an inverse. You okay? Might as well start with a complicated one rather than not complicated. Don't you hate it when the teacher gives you easy examples in the homework or not? Okay. I don't want to be perfect. All right, now. So we've agreed right now. Now, first of all, what's f of x the same thing as? Y. So if it makes you feel better to change that to y, then change it to y. So we agree that our x's are our domains, right? And our y's are our what? Ranges. So that's going to be important in a second. Now, so now we decided, if you put that condition on, it is one-to-one. So what am I gonna do? I'm gonna solve for what? X. How are you gonna get this? How do you get rid of that square? Take the square root. Now, so what's the answer on the left side? Is that it?
No.
That's not it. What's the answer from here to here? What did you do both sides? You took the what? All right, now, let's teach you something that apparently nobody taught you. All right. All right, what's the answer to that? Just two?
Positive, negative.
Where'd that negative come from?
The unsquared.
I mean, over here, y'all are perfectly happy just to take the square root of y, put the square root of y, right? So why over here we're not happy just to put the square root of 4, which is what? 2. So, what? I don't understand. All right. Here's where somehow it went all wrong. What do you think the answer to that is?
Could be positive or negative.
The square root of x squared is not x. Okay? The square root of x there is the absolute value of x.
This morning got questions.
All right? Now, here's how you already knew that. Here's how you knew that. Oh, I stood this way, like a man. You're like, oh my God. Okay. All right. What's 3 squared? 9. All right. What is the square root of 9?
3.
This matches. What's a negative 3 squared?
9.
What's the square root of 9?
3.
Those don't match. So the square root of x squared isn't always x. Are you with me? Sometimes it matches and sometimes it's the opposite. Now, this is what they should have made you do. The square root of 4 is just freaking 2. But this has 2 answers. What 2 numbers have the absolute value to be 2? Positive 2 or negative 2. But somehow they make y'all, I don't know how this happens, it's the weirdest thing I've ever seen. They go, I'm like, where'd that come from? That's where it comes from. So you're welcome to do that, but you understand now why you do that. So over here, technically, you're supposed to get a positive or a what? Negative. Now, I'm going to drop the negative in this context because look at your picture. What quadrant are you in? 1. Is anything negative in quadrant 1?
No.
No.
We do that all the time. We're just.
I know, y'all were just messing with me. But does that make sense? Because a lot of times on that third picture, y'all won't have your graphers. And I will literally tell somebody to graph this. And they can't graph it. What's that graph? A circle. But see, here's what they do. They go y squared, you see what I'm saying? They said this freaks them out. You said they just panic. It's like, can't you make a tea table? Or it'll be something simple like this. I think. What's that graph? Parabola. But it's not an up down, it's a what? Right left. Everybody with me? But here's what they do. They'll go, well, y squared is x minus 3. And they go, y is a square root of x minus 3. You know what they graph for me? Half the parabola.
Okay.
Because it's not this, it's this what? Or what?
The other half.
The other half of the parabola. But for you to make the grapher do it, you got to make the grapher graph that, and then you got to make the grapher graph that. You're smarter than the grapher. Okay, so over here, this is correct with an addendum. Now, what's your last step with these X's and these Y's? What do you do with them? You what?
Switch.
Switch them. So Y is going to be what? This positive square root of what? X. Now, here's the deal. Up here, what your X is, but in other words, here, if your domain is greater than 0, down here, that means your Y has to be what? Greater than 0. You see what I'm saying? That's why I got to drop off that negative. So if the domain is restricted going in, guess what's going to be restricted coming out? The range. But all you do is just take them, solve for Y, and then do what? We solve for X, and then do what with them? Just switch. And that's more complicated than the ones you have for homework. Okay? So the two things that they're going to ask you to do, they're going to give you two functions and ask you, are these functions inverses? How are you going to decide if they are or they aren't? You're going to do compositions both ways. What should you get? X or the independent variable. Okay? If they give you one and say, find the inverse if it exists, then what's the first thing you better do? You better double check and make sure what? That it has a what? An inverse. Is everybody okay? All right, find me the inverse of this one then if it exists. You got your graphers if you want them. I'll make it f of x because they're going to be f of x. So find me the inverse of f of x if it has an inverse. Does it have an inverse? Yeah. Isn't that like an S curve? All right, so you check it on your grapher. So now you're going to go find it. Now, what can you change f of x to if it by y? So what's my next step to solve for what? X. Okay, get rid of the -4. What do you got to do both sides? All right, so I've got x cubed going to be y plus 4, isn't it? Now, what have I got to do to get rid of the cube? Take your cube root. Now, the cube root of x cubed is x. So I get the cube root of what? Y plus 4. You solve for x. What's your last step? Switch them. So what's x turn into? Y. And what's y turn into? X. Now, the back of the book doesn't usually put y there. Instead of putting y, they're emphasizing this is the inverse of what? F. You can leave it that way. That's good for me. But the back of the book is probably going to put F inverse of x. Is that? And again, if you want to make sure you're right, do the compositions, and you better get the independent variable x back both ways. Okay? Everybody okay on finding inverses? Now, since you've already got your grapher out, and I have like 7 more minutes, this will make next week go a little faster on Monday. All right, most of y'all are comfortable doing y equals x, x squared. Now, you don't have a problem with that. Okay. But you get real uncomfortable when I make you do this. y equals 2 to the x. Okay, so take your grapher and graph that one for me. Y equals 2 to the x. You got it? All right, now. What's 2 to the 0? We talked about that already. What's anything to the 0 power set 0 to 0? 1. So when x is 0, y is 1. What if x is 1? What's 2 to the first? That's just what? 2. If I got 2, 2 squares, 4. I mean, is everybody with me? Now, what if it was a negative 1? 2 to the negative 1. What's 2 to the negative 1? The same thing as 1 over 2 to the positive 1. We talked about that when you move things from numerator to denominator or vice versa, the sign on the exponent changes. So I get a half, don't I? So at negative 1, I get a half. At negative 2, I get, everybody with me? So your graph should look something like that. Is that what it looks like? All right. Then graph this one for me. Y equals 3 to the x. So you got the grapher. You can do it by hand with the T-table or do it with the grapher. What's 3 to the 0 still? 1. So they have the same point right there. What if I had a 1? That'd be 3 to the first, so that's what? 3. So instead of 1, 2, it's 1, 1, 3. Instead of 2, 4, it's going to be 2 what? 9. Is everybody with me? If I have a negative 1, won't that be 3 to the negative 1? That'd be 1 what? Now, is 1/3 bigger or smaller than a half? This is that graph. You know what E equals? E is about 2.71. What's pi about? E is an irrational number like pi is an irrational number. It's one of those decimals that just goes on and on and on. So we're not going to panic when Dr. Gann tells us to graph y equals e to x. Isn't E a number between 2 and 3? So that graph is just going to look like this. It's the black graph. Nothing weird, unusual, freaky. Just a number. Now, they're going to ask you things about domain and range on this graph. Look at the black graph. You can look at any of them really, but the black graph is y equals e to the x. What's the domain? Where do you have x values? Everywhere, right? So my domain is going to be all real numbers. Okay, what's my range though? Like, look at the y values. What should you notice about those y values? You never have anything down here, so it's never what? It's never negative. Is it ever even 0? No. So what's my range going to be? Positive, right? Now, the back of the book, we're probably going to write it like this. Instead of putting positive numbers. But I don't care. They're positive numbers. All right? We talked about x-intercepts and y-intercepts before, right? Okay, does this thing have an x-intercept?
No.
It doesn't touch the x-axis. It doesn't have an x-intercept. Is everybody with me? Does it have a y-intercept? What's the y-intercept? Where does it touch the y-axis? Right there, right? What's that point? Is it 1, 0 or 0, 1?
0,
0, 1. Is it a function? It is. Is it a one-to-one function? Yeah. Well, if it's a one-to-one function, guess what it's going to have? It's going to have an inverse. Now, we're going to talk about it next week, but that's where logs come in. What's going to happen if I want the inverse? What can I do with these points? Flip them. So the inverse, what's the domain going to be on this log function we're going to talk about next week? The domain for the inverse is going to be what? Positive numbers. You don't get logs of negative numbers. So the domain is going to turn into the range, and the range is going to turn into the domain. Is that log function going to have a y-intercept? No, because it's going to, you see what I'm saying? What's going to happen to these two things? They're going to what? Flip. Now, where's your homework going to be? On Moodle. So it's going to be some out of the book on inverses and then a trig worksheet. Everybody with me? Now, those reviews, I'll try to have them ready by Monday, but I don't know which of them by Wednesday. Come see me if you need some help.